In this video, I'm showing you how I created shadows in OpenGL using C++. So as you can see here, I'm flying around and we have these three crates on a wood floor, and we have a skylight which is casting these three shadows. And the containers have their own specular reflections. And then if a container blocks the sunlight, it casts a shadow. Alright, so the way this code works is we have a shadow frame buffer object which draws a texture to it, and we render the scene, but we render the scene from the perspective of the light. And this allows us to get the depth values of all the objects in the scene. So this sets that up. And so down here we have the shadow code, which sets up an orthographic camera, and it makes us look from the light position to the center of the scene. And then we render the scene using the shadow frame buffer object. And then after that, we render the scene regularly, except we take the texture that was generated by the shadow frame buffer object and we pass it in as GL texture 1. And down here, we just have render scene as a function so that it's easier to call twice. Then in our vertex shader, we take in light space matrix, which is the transform used by the shadow calculations, and then take in projection view model and do all the regular 3D calculations. And then in our fragment shader, we take in a diffuse texture, a specular texture, so that's for the crate and the wood floor, and we take in a shadow map. And then we calculate shadow with this function here, which what it will do is it gets the current depth, which is the projected coordinates from this equation here. So we just take the light space, the frag pause light space, which uses the light space matrix, and then we compare it against the depth of the shadow map. And what this will let us do is tell us if an object is in front or if another object is blocking it. And if another object is blocking it, we increment shadow by 1, and then we divide by 9 because we run this 9 times. This just helps us smooth out the shadow. And then down here we have fairly standard ambient, diffuse, and specular code that calculates lighting. Just at the end of each of the calculations for diffuse and specular, we times them both by the shadow value, and we get that by running the function. And then at the end, we do a gamma correct, which raises the lighting to the power of 1 divided by 2.2, and then we run the results. And for the gamma correct, one other thing we have to do is in our texture loading code, we take in an internal format, which allows us to specify something different here. And we use that down here where we set both the wood texture and the container texture to use GL sRGB alpha, which undoes that gamma correction calculation. So when we run the code, we get a more clean lighting, however the textures are unaffected. And if you're curious about the basic lighting setup we have here with ambient, diffuse, and specular, or you want to learn about this halfway dir that I started using, you should click on this video here where I explain those two things with a similar scene, but without the shadow calculations. So if you're interested, click here, and until next time, see ya.